This conference will now be recorded.
All right, cool. Well, thanks for coming along, everybody. Today we have Chris Holmes from Planet Labs to give us a talk about the SpatioTemporal Asset Catalog specification and the activities that are going on around that. I've been really interested in hearing about it, and yeah, it should be a good talk. And just a note for the next call, I lined up a presenter from Google Dataset Search for next month. Everybody should have gotten the notification about that already, and yeah, we're all set. So with that, I'll pass it over to Chris to give us the lowdown on STAC. Thanks, Chris.
Cool. Thank you. So yeah, my name's Chris Holmes, and I wear a few different hats that kind of nicely all converge on SpatioTemporal Asset Catalogs, also known as STAC. So Planet's my main gig, do product management here, kind of helping disseminate our satellite imagery to everybody. I also am a technical fellow for an organization called the Radiant Earth Foundation. They're working to bring satellite imagery to kind of more of the development community, make an impact with it. And they convened the STAC. The first STAC thing was them sponsoring it, and it lives at their GitHub. And then the other hat that sort of fits into this a bit is I'm on the board of the Open Geospatial Consortium, which is the main standards organization. So that's just sort of where I sit, and you'll see, I think, as I talk about this, how many of those sort of come together. So I think at least some people have heard of STAC. It's come up, I think, on these sessions before, but just, for the why, in my words, pretty simple, especially why we even started this, is there's, to find geospatial imagery, there's a whole bunch of different data portals you have to go to. You can't just kind of search one place and get imagery. You can do that on Google and get most of the web, but I want an image of this place, I have to go to Planet and Digital Globe and Sentinel Hub or another Sentinel portal and Landsat, and then then I'll get all the imagery for the area I care about. It's sort of even worse for from the API side. Like, each of these has a very custom little API. So one might call it cloud cover, one call it max cloud cover and min cloud cover. They're pretty much all RESTful JSON. They're all roughly the same and feel the same, but you have to make a new little client library for each of them. So that was sort of one of the motivations of STAC, and sitting at Planet, we also had a RESTful JSON API and looked at everybody else's, said kind of, can we bring it together? The other major thread behind STAC is this idea of making geospatial specs a bit differently. And a lot of this is sort of drawn on my background that led to how we go about STAC. So I led GeoServer from early days 0.14 all the way to 2.4, and kind of have been deep in the open source collaboration, and tools like GitHub are super awesome. The open source world, I think, has innovated on collaboration more than the kind of traditional spec world. I also implemented the WFS, WMS, other people did WCS, but it was when I was there, specs in GeoServer. But I got, kind of 2006, 7, pretty disillusioned by the complexity of these specs. They just kind of added more and more and more that weren't really, thought through for a developer. It was just, oh, we should have this, and they got to really complex. I was actually pretty much done with OGC, and then was recruited to join the board to kind of give this message one last time by Chris Tucker, who's a good friend and ally. And he was like, look, try to deliver this message about what needs to change. So I did. Before I started to be really pushing them, I worked on GeoPackage 1.0, to do a specification, from the ground up within the OGC, and kind of help do that a little differently. And things like, it was the first OGC spec on GitHub, and that was me just copy and pasting the Word document to be on GitHub. But it was on GitHub where you could read it. It was at least HTML you could link at, but people weren't working on GitHub. They weren't collaborating. They weren't using all those tools. And yeah, have been sort of inspired by Geo JSON and Carter CSS and these specifications made outside of the OGC, made to be a bit more accessible. So with STAC, we kind of started with this set of core principles on how we're collaborating and tackling this problem of sort of imagery search interoperability. So embrace the open source best practices, JSON, REST, HTTP at the core. Really, small reusable pieces loosely coupled, which I tried to bring to GeoPackage, didn't quite get there. But if there's a little component, like let that live on and not wrap it to the rest of the big spec, and then really focus on the developer and the implementer. That's the audience for a specification. So make it so they can get their heads around it, and put it in their tools, and then just, I think, common phrase, we believe in rough consensus in running code. Work with the code and figure out the spec from there, as opposed to build the tower and then make people implement it. So that's the kind of motivation coming to STAC. So what is STAC, Spatial Temporal Asset Catalogs? So it's really a language for geospatial catalogs and assets. It's focused on search and discovery. It's very simple, and I can show this to you, but I think it often sounds, I've heard people say it sounds more like a big monolith, like STAC, and just kind of lands on you, but it's really just a few JSON fields that are aimed for interoperability, and then it's extensible. So lets people put what they want onto it, uses JSON, which is quite extensible, so you don't have to necessarily be a schema. You can mix and match a few different things. It's all open source, all fully open, all development of the specs done in the open. Anyone can put a PR on it. And then, there's some interesting things with kind of static catalogs, and then we also do an API. I'll get into that. So what is it not? So we're not a full-fledged metadata standard. We kind of see ourselves as the layer on top that makes that big metadata standard more accessible, more searchable, put it into an API, put it on the line. It's not your single source of truth. It's not a replacement for ISO 19115, and we're working more to sort of make that alignment even clearer. But think of, ISO 19115 or, FGDC as that's your core metadata. You might have a STAC version that helps enable that search and discovery and human use of it. And we're not covering all kinds of data sets. We're limiting to kind of things that have assets. So you don't want to really reference a shape file. Like, we're not trying to catalog everything. It's very specifically for when you have a whole bunch of files, and it's the web presence that lets you get at those assets. So it's closer to like EBRIM CSW, if people are deep into that, as opposed to the more general CSWs. So kind of time frame, this has all happened relatively quickly. October 2017 is the first, didn't even have a name, came together, did this kickoff meeting. And then we've had a lot of success from these in-person sprints. So we've done 3 of them, and it's kind of bring a bunch of people together for a couple of days, have some dedicated space to work on this stuff, and that kind of generates a whole bunch of stuff and advances to the spec. And then we kind of clean up afterwards. We actually just did a release with 0.7.0, which is our first major release without an in-person sprint, and kind of just pure online collaboration, which was nice to see. But I think we also felt like, getting a day or two together, just hash things out is preferable. So we have another sprint coming up in, this one's actually quite long. It's in first week of June. No, that's right. To push forward that next version. So who's involved in this? So it's actually quite a few different diverse companies, and indeed I really wanted a lot of the more kind of vendor side of things to start. So Digital Globe Planet on the data side, Development Seed, Earth Engine, Boundless, Hexagon, Pixia on the kind of software side, Harris, and then governments as well, and it kind of, can we have this broad swath of people? And we've got 29 people who've contributed on the GitHub. there's 10 who have done at least 10 commits, so we've got kind of like a smaller core group. It's probably like 6 or 7 of us that show up at bi-weekly calls and kind of advance things. But really, I mean, for getting lots of feedback from a broad coalition of different types of people. So what's in that specification itself? So it's kind of 4 pretty loosely coupled pieces. We try to make it so you could use each independently, and there are some use cases for using them independently. And I'll talk through each of those. And then there's a kind of rich set of extensions for people that are doing a bit more with it or want a bit more specificity for their data type. So one of the core things is this catalog. So catalog is super, super simple. It really is. It's a JSON object with 2 things. It's either links to other catalogs or links to items. So it's really just this sort of organizing principle. It's like a sort of almost directory structure, but it lets you crawl things and you can really kind of organize it however you want. And then there's a thing called a collection that extends the catalog. And this is where you actually add your metadata at that sort of collection level. This is a set of items that are all the same. So I can talk about, they're not going to differ. They're more homogeneous than heterogeneous. It's pretty cool though. Some people actually use the collection standalone, so they don't have the items to search through, but they found this to be a useful little bit to represent their collections of data. So Google Earth Engine, you can take their data catalog, which is probably 400 different data sets, and they have a STAC collection of it. And again, it's very simple. It's just kind of a little JSON thing, but it makes it machine readable, where you can point at that and get stuff from it. And then the OpenEO project in Europe is kind of a layer on top of things like Earth Engine, these kind of data cube n-dimensional compute engines that abstracts it away. And they also have a catalog that just uses the collection, because they don't have items when you have, an n-dimensional data cube that you're, just doing operations on the fly from. You don't think about the individual granulars that go into that. But we also, everyone sort of wants that indexing at that scene or granular level so that can be input to, your data cube or your X-ray or your kind of bigger thing. And then collection is also compatible with WFS3. And that's one thing we've tried to do, is align with that next generation of OGC specifications and kind of dialogue with them. So we have a few more fields than WFS's collection, but we're even sort of pushing to maybe get some of those into WFS3, so we don't even have to have that collection concept in STAC and can just point at WFS3. So then there's the item. So this is a Geo JSON feature. It has properties. The only required property is date time. So let's make it spatial temporal. You need to say when this is from. You can't just say, oh, this is, just not bounded into time. And then you can have any additional properties. So there's extensions for things like electro-optical or SAR that have your GSD, your cloud cover, your orbit, absolute orbit number, whatever those fields are. And you don't have to use those. You can put your own things in, but the idea is to kind of more bottoms up, get a sort of consensus built set of fields that people can use. And then it links to its downloadable assets. Now, downloadable, but also accessible in the cloud. So I don't talk about it a ton, and hopefully people know about cloud optimized GeoTIFF. If not, we can go to some appendix slides on it. But STAC's really compatible with cloud optimized GeoTIFF, and this little view and animated GIF that's going, that's just a STAC item that points at that GeoTIFF, but that little map view is able to be generated directly from that asset. So the idea is kind of be more cloud native. That asset is a link, but you can also just hopefully pull it directly instead of download it, use it, and stream it into your cloud service. So yeah, these items really shine with cloud optimized GeoTIFF. But again, they're not required if you have some JPEG 2000, NIDIF, point cloud LiDAR data, whatever it is, you can link to it. It's orthogonal to it, but there's cool new formats that stream super well online. So we're in preference of those. So then the last piece is the API, and it's kind of interesting. We started in the first sprint, about the API, and that's certainly where I came from. Planet had an API, but we've ended up abstracting most of it to not even requiring this API layer. It's just these catalogs that publish and let other things crawl them and potentially search them. But the API basically lets you search. And with the second sprint, we worked to align that API with WFS3. So it's an open API document, has those same WFS3 collections, lets you search across all assets with filters, and that WFS isn't quite there yet. But it's pretty simple. It's just that it's that API that powers the little satellite search engine where I can put my cloud cover filters and my look angles and whatnot. It's just that REST API behind it. And it builds on top of the other components. So all the fields, all the JSON returned is the same. And then, we've got a growing ecosystem. There's STAC browser, which you saw there, and I'll talk about a little more. There's a validator, and that to me is one of those really important tools, in developing a spec. Instead of having to read every single bit to, think that you got the spec, just be able to plug that plug your version into a validator and let it tell you if you made it or not. So STAC crawler, stat utils, and then there's a few services. You can click on this link and see a whole lot more. So that's the kind of core of STAC. And then I just wanted to riff a little on some of these implications that come from this. It's a core simple thing, but I think there's some directions that can go that get quite interesting, and then where are we going in the future? So one of the things I alluded to a bit is this notion of a static stack, and this actually just kind of came up in the first sprint. We had a suspicion this might be important, but I think this is one of the most unique things about STAC, which is this notion of making an API that is not powered by a server. You have Amazon S3, Google Cloud Storage, Azure. Those are APIs. They're very simple APIs. They just put data available. But if you construct your links correctly, you're able to have a crawler go through it and have it essentially serve as an API that apologies, getting over some sickness. So you can navigate and you can put your data available by just publishing JSON files onto Amazon S3. So yeah, this is showing a Google Cloud bucket that I have of Planet data. And it's just a bunch of files I put up in a folder structure and a link structure, but it fully implements the STAC item and catalog and collection specifications. So no moving parts, super robust and reliable, can be a backup on top, behind a much more dynamic service. And then the other cool thing is you can actually have a STAC API ingest this. And we've seen a few services that do that, where that core is the static stack, but an additional piece of software enables the search on top of that. So then the next piece is, we really wanted to embrace the web, not just do JSON, but do HTML. And originally I thought we might make an HTML version of the specification, but what we actually got to is in many ways a lot cooler, which is automated tooling. So the STAC browser is what you're seeing right now. And basically this full web page, full experience, including, the listing, including the bounds, including this map that I can zoom in and pan and move around on, that is all fully generated from a static stack. So we just taken that core JSON, and since it's structured in the same way, and it has a cloud optimized geotiff, we're able to generate this web page kind completely with kind of no moving parts. And, it's like, to me, how do you make this stuff more accessible? How do you make it so I don't need a desktop GIS to even just look at data, to share data? How can I, with all the past standards, like if I want to just send you a link to something, it's not clear what I send. It's, you maybe get some JSON response. This kind of puts a single canonical page for every asset that you have that can just be referenced online. It can be crawled by search engines. So I think this has kind of a lot of implications that says, instead of just, I have my index and I make it available, it says put this online and let it so people can find it and the kind of broader web can find it. And so, yeah, this core philosophy is that, like, Google is better than a bunch of data portals. Having to know where a portal is, search from it, even a set of federated portals. I think the metaphor that certainly works better for me is, something like Google should index everything. But it's not just Google. Anybody can index the web in the way that they want. And we should have the same thing for geospatial assets. They should be able to be indexable by any search engine. Normal searches, and then you can see specialized geospatial search engines. But STAC's kind of focus is let's make more data accessible. It's not saying let's solve this full search paradigm and make search. It just says let's get the data in a form that can be crawled and can be used. So we try to limit ourselves to just that sort of unique problem. And yeah, so all these different data portals exist, but yeah, ideally this helps us get to more of the long tail. Right now, to put up data, geospatial assets, satellite imagery, LiDAR to share, it basically puts a huge burden on the data provider to put up an index to make it searchable. But I think we could get to a much longer tail of products if it was as easy as just uploading to S3, running a script, or just having some easy tooling that lets you put it up, but then you get a whole lot more value from it. Then you go into other APIs, then you go into HTML. You kind of need to show that value that you get from publishing your data. And we've started to experiment. This is still super early, but with how can search engines like Google actually crawl the data? So I think I'd do this one a little too quick. I could maybe jump, but you put in this ID, and this is a very specific one. I think we want to get to the point where you more just search, imagery of hurricanes, and you'd get a page like this. But, right now I can't take a Landsat ID and stick it into Google. Even though I work with Landsat, I know what this is, I can't have that meaningfully get back information. So the idea behind this is make every single page that's generated from that core STAC JSON be compatible with the search engines, with dataset search, with schema.org, JSON LD, but do it at the level of that browser. And then once you have these pages that exist, you can see links in that sort of normal way, building up to them and getting page rank and going up and up in search engine optimization rankings. And I think there's more work to have these be more search engine optimized and have more information so that each is a landing page into satellite imagery. But how do we get to that point where people can just Google for imagery, for point clouds, for SAR data, for any type of data set, and actually be able to get a preview of the data, be able to use the data online, and then optionally download it or use in another online cloud native geospatial streaming system. So then the other sort of thing to talk through a bit is OGC and where we fit into all of that. So initially we started STAC to be sort of outside of OGC in a way, and to bring back this new way of working into OGC, and kind of show, hey, we're searching geospatial assets, but these are the same as sort of any feature. But the super cool thing is that right around the same time that we were starting this up, OGC kind of did this flip to WFS3, and actually, they had published a document called Spatial Data on the Web Best Practices that articulated a lot of ideas that were much more in line with how the STAC group was thinking about things, but it hadn't manifested as specification, but the web feature service group really embraced these and kind of ran with it with WFS 3.0. So in the second STAC sprint, we actually co-located with the WFS group and kind of brought in a lot of the open source developers and energy to that. But our goal is really to align with what they're doing. And yeah, they are kind of started with this WFS spec, which is features, but it's actually kind of overtaken the whole organization of a next generation set of APIs. And they're doing these things fully on GitHub. Anybody can make pull requests. They're much smaller cores. They're much more embracing the web and REST, and it's really exciting to see kind of that group. Now, STAC, we're continuing to push forward on ours, but we see it as a kind of dialogue with them. And yeah, people sort of ask, how does STAC fit into OGC and vice versa? Like, our ideal for STAC is actually that it's much less, that we could not even maintain the STAC API. We do have that API and that open API document in our repository, and we actually diverge a little bit from WFS3 at some points, mostly because they haven't quite finished all the pieces that we need. But the goal for us is to be in dialogue with them and kind of take our extensions and put that back into WFS. If WFS does stuff, we can adopt it. And yeah, ideally, we're just focused on the content for spatial temporal assets. And yeah, we would love to be sort of mostly subsumed by other standards. What we're hoping to do is we help show this sensible implementation-driven way of working, but also a really collaborative way of working with kind of everybody else, and make our spec as minimal as possible and kind of focus on that search pieces. There's more work needed in the OGC baseline. For STAC, we need this collection. We do cross-collection search options, which aren't really in OGC WFS3 yet. And then, yeah, a lot of questions come about CSW. Where does STAC fit into that? And basically, I think with STAC, we want to see what this next generation CSW and this new baseline at OGC looks like, which, yeah, I'm personally pushing to be very compatible, if not the same as WFS3. And then once you have that, I think we can fit STAC as a little kind of subset of just a content type or a specific thing underneath that CSW. Yeah, I kind of bounced around a bit and was a bit of a dump, but hopefully we get some questions on relevant things. My last slide is, join us. We try to be a super open community. We're on Gitter and GitHub, and everything we do is in the open. And these sprints that we do, everyone's welcome to join. The next one is in about a month at Planet's office in San Francisco. There's a sign-up form there. I'm also going to try to do some virtual sessions that anybody can join and kind of work on your own thing. And the goal with this sprint is to actually try to shift away a bit from so much just modifying the spec to actually just building up the ecosystem, working on the tools, and working on converting more and more data into STAC and putting it out in the world. And then, yeah, this OGC API Sprint, I very much encourage people to go to if you're interested at all in OGC standards, especially if you're come from more the developer land and have been at arm's length. They are really making a concerted effort to enroll developers more and have that define their new baseline. So it's bringing together, I think, WFS along with coverages and processing to sprint on this. And, I think the OGC is kind of more open to this open sourcey, RESTful JSON energy than they've ever been. But I think it's also on all of us to kind of meet them halfway and help them evolve and help make those specs better. So definitely great if anybody can join for that as well. And I think that's all I got for now. And I think we have a good bit of time for questions.
Sweet. Awesome. Thanks, Chris. This is totally awesome to see. Having watched this stuff for the last 10 plus years now, I had a very similar experience to you, getting pretty disillusioned a little later than you did, but pretty disillusioned with things in the OGC space. And it's so refreshing to see this stuff really starting to catch on. And Aaron Robinson and I are both now on the OGC architecture board and are probably the biggest cheerleaders for some of this more open, more quote unquote webby approach to the OGC specs. And anyways, very, very good to see. So thank you for your advocacy and the direction you're taking things. It's really good.
Awesome.
So I guess it looks like we have a question in the chat, maybe. Can you see that chat?
You probably can, yes. How do you foresee folks citing data that they discover through STAC? I didn't see anything like a persistent identifier, e.g. DOI. So yeah, so the core stack is like so simple, it's not even funny. And we have a pretty high bar to put stuff in that. So yeah, it's really just space and time and links to the assets. And then the way we kind of bring more into that is started in extensions. I don't think we have a kind of DOI persistent citing. No, that's not true. There actually is a scientific citation extension. Yeah, we'll go. Not quite live demo, but let's see if that is what I'm thinking of. So this is the STAC repo where everything sort of happens. Scientific. So yeah, we have a DOI item field. So basically, and this kind of speaks to extensions. This is still a proposal, and we have this maturity classification, so people kind of know like how far along is this. So this is, and really basing this on how many implementations exist in the world, how much can I count on this being a thing. Most of these extensions now are pretty much in proposal or pilot, but I know OpenEO, who's definitely a major user, is using this one pretty extensively. And basically, you can layer these fields into any collection or item that you would like. So yeah, there's a DOI citation publications, and yeah, if we're missing something that kind of fits in this frame, feel free to make a pull request and put it in your catalog. It does remind me of another thing that is near and dear to me with STAC that we haven't done that much on, but is one of the reasons I want to do STAC, which is provenance. And we do not want to invent a provenance specification, but we did actually add one field that's an optional field, just to give kind of a hint of this. So yeah, this is the actual spec, so you can kind of see. I mean, you can poke around yourself, so yeah, it's in. So we basically have assets linked, and then we have links, which is kind of embrace the web and describe your relationship with the other thing. What's the parent catalog? What's the collection? But we added this, very simple derive from, but so you could kind of track like, hey, this piece of STAC came from this. So Landsat data is on a few different clouds, so be able to say it came from there, or I ran a process, a pan sharpening or an NDVI, be able to link back to say, hey, this is where I came from. And I very much feel we're moving to the cloud, to cloud native processing, and we're at this moment where if we get right those links back and just kind of automated metadata generation, we can build much richer search engines, much richer information systems than we have in the geospatial world now. So very much in support of tracking provenance, and yeah, like any a raster foundry or a Google Earth engine or the X-array stuff, anything should, when it's doing an operation, hopefully generate STAC or other metadata. I'm not even super tied to that, but this is our attempt to make that easy. That points back to, hey, I did this operation, this thing, or this is where I got this thing. And I think if we get that, we're going to have much richer ability to mine geospatial data and get insight from it than we do today. Did that answer your question? And a little more?
That was great. I see Rich is unmuted. Rich, do you have something?
I guess it was just to make sure I understand. So on the API, on some of the APIs that have been implemented, when you do a query, it's actually going and reading all the catalog items from various objects on the fly, or no?
Generally, no. Well, so yeah, there's a couple different implementations. So SAT API that I'm at right now is open source implementation on Amazon Web Services. And yeah, you can see it's got Landsat and Sentinel. Let's see some items. Yeah, it's got like 1 million Landsat items indexed. And so it generally is like it works by ingesting a static API, or yeah, so Landsat isn't quite implementing STAC. Actually, they do have, no, there is a static Landsat stack, and they are reading from it. So yeah, I think the SAT API, it's sort of up to the implementer. For SAT API, they do an ingest step and then store it in Elasticsearch for that responsiveness. And kind of just reference their own copies, which lets you kind of rewrite the links a little better. So they kind of aren't referring to the original thing. But then there's a CBERS data set that they actually refer directly to the static ones. I kind of slightly prefer just an ingest step. And then the key thing that there's a nice blog post on, we haven't standardized it yet, but using things like SNS and SQS, simple notification service and simple queue service, like if you have a static catalog on S3 or Google Storage, it's quite easy to make a little subscription thing that says, hey, when something changes, let the others know. And so you basically have your dynamic API, like SAT API, points at these SQS, SNS for the static catalogs, and then it reads and updates. So it's able to kind of stay up to date with its ingested database in Elasticsearch from the changes to the static catalog. But yeah, from the spec level, it's an implementation detail. Like we don't say, you need to do one or the other, and people have done both. For whatever reason, I slightly lean towards an ingest step, but then you kind of always have the static catalog. So yeah, if your Elasticsearch cluster blows up or your database blows up, you can just replicate that very easily because you have that static one. But you get a lot of advantages from kind of having it in an index in memory, and it's pretty easy to rewrite those fields. And that's where you would use that derived from provenance field to say, hey, like I am this stack item, I'm serving this up to you at this URL, but I'm really just a copy of this static stack. So I can search back, where did I actually come from?
Got it.
Does that make sense?
Yeah, totally. No, that was great explanation. Yeah.
Cool.
Yeah. So let me ask. I've got so many things I could ask about. One, I guess the big one that I wanted to bring up is a project that I've been working on recently that actually in the next iteration of the work that kicked off in the last few weeks, we're going to be testing WFS3 to basically be the backend to a linked feature catalog, using some of the spatial data on the web best practices and some linked data formalisms, but being pretty skeptical about the linked data formalisms.
I'm with you on that.
And one of the one of the use cases that I found most interesting there is, like, say you had a lake or a little watershed or something, and you wanted to be able to index all the Landsat scenes available for that lake or that Landsat scene. It seems to me that the STAC spec would be a really convenient web kind of artifact or resource that you'd be able to use as the artifact you would link to. Yeah. And I'm just wondering if you've seen anybody thinking about that in terms of a kind of linking between the spatiotemporal assets and real world entities.
Yeah, that's one of the things I'm most excited about. And yeah, I'm glad you got, I've had people that just, they're like, they want to put that lake in STAC. I'm like, no, like that's a lake, that's an online resource. That's not STAC. That's like the only thing that's not STAC, you know, like because it doesn't refer to a file, you know, like you can represent the entity fully online. So just do that as a WFS3, you know, link object. But yeah, from that thing, which is that, you know, like crescent, like it should ideally have a bunch of links that say, you know, this is an image of, or I don't know, semantics that you want to choose. But yeah, I think I'm going to say there are many Landsat links of this lake. And yeah, I could see a few different implementations. Yeah, like the naive one would just link to the scene where it's contained. You could see cooler stuff where it like, you know, maybe has the bounds of the lake and combines that in some unique way. But yeah, I think there's lots to play with, but as a source, like, you know, this is the Landsat scene that contains this lake, like it should work today. And yeah.
Right, so like somebody could write a crawler that would go and crawl the STAC catalog and use the metadata there to figure out which Landsat scenes go with which lakes.
Yeah, like that should be pretty easy.
Cool. I mean, and that's the work we're doing is actually saying we need a index page essentially for a lake that might point to 5 different data sets that have information about it, right? Yep. And that's the WFS3. How does WFS3 fit into that kind of a framework? But anyways, that's a whole nother talk. Come to Google Dataset Search next month.
I'm excited on that one. Google Dataset Search is definitely a target for us with STAC.
So you got another question about ISO 19115 here in the chat.
Yeah, so no one's made it yet, but we want to. So yeah, it's definitely one of those bubbling up, and maybe I'll just take an attempt at it. I don't really know ISO 19115 that much, but yeah, that like state we should get to in the ecosystem is just auto transform ISO 19115 to STAC. I think there's a bit of work to do of like what is the STAC profile or extension that represents ISO 19115, which to me is mostly use their fields, map, date, time, and possibly a couple other fields to STAC, and then link back to that ISO 19115 as one of the main assets. So it shouldn't be that hard. I think it's just none of the core people who have put more time into it have had that particular problem yet, but yeah, would love that contribution.
That'd be something to look at. It's actually an ESIP hosted resource that Rich, what's it called these days? The Attribute Convention for Dataset Discovery?
Oh yeah.
Is that right?
Yeah, that's you mean that's one example of such mapping or something? Or
yeah, it's a space where mappings exist from a few different spatiotemporal metadata conventions that map onto ISO 19115 classes. That would be a nice place to contribute some additional mappings or some kind of similarity statements for these STAC elements map onto these other elements, say in the threads catalog or in NetCity FCF. I think those are the two that are in there. But anyway, so maybe put a pin in that. That would be an interesting little piece of work. It probably wouldn't take very much to do.
Yeah, and I know the OGC architecture board, when they first looked at STAC, that was their immediate thing, was we should have a mapping to ISO 1. I think it was ISO 19115, but I don't think anyone ever moved on it. But yeah, I mean, at the next sprint, I'm hoping to I think we will have some people who are newer to the community, but able to do some stuff. So I'm hoping to have some topics of, hey, you don't have anything to sprint on. This would be a great thing to sprint on. I'd say, if anybody on the phone wants to some extent, an excuse to have 2 or 3 days where you can ask your boss, either come to California or, even just dedicated time and work virtually to, work with us on that problem. That'd be great.
Great.
Yeah, this is Rich. Rich Signal. Yeah, Dave, actually, when you mentioned ACDD, this attribute convention for data discovery that ESIP, under ESIP, actually, I was thinking, gosh, it would be great to get that out of Wikidom into GitHub as well. It feels a little bit like OGC over there. It's not very transparent what's going on. And, but yeah, maybe it would be nice to sort of harmonize this effort with that other effort of sort of mapping, NetCDF attributes and stuff into ISO.
Yeah, I agree.
Actually, that brings up another. I know there's some Pangeo folks on the call here. I think Chris, you had a conversation with the Pangeo folks about how well STAC would be used for sort of MD array data. I don't know, maybe what are the issues there, or maybe I don't know, maybe one of the other Pangeo guys, Chris or Joe, can comment.
I was going to ask the same question, and I guess from my perspective, it's also kind of for n-array data where you have multiple variables and not necessarily multiple bands. Like, is there much thought in the existing STAC community into that more multi-variable model kind of data?
Yeah. Yeah, so we had a very productive conversation, with a bunch of people from the community and a few STAC people. I think we don't have like a volunteer to run with it. So there are a few things that came from it that seem practical. And yeah, I think I should follow up on them too. I mean, it seemed pretty easy for like a thread server or an OpenDAP server. Like, they seem pretty good at like implementing lots of APIs. So they could likely implement a STAC API relatively easily. And indeed, like even Planet or Digital Globe, like it's actually sort of easier to implement the API because you already have your index, you can like map stuff to it and kind of put that out there. Yeah, I think there are some things on the model, like, so I think there also was like a group was kind of interested of like, could we use STAC sort of almost as our native metadata description format? And I think that's a little more of a stretch, like just because, yeah, the n-dimensional stuff introduces some interesting things. So I think where we got to, like, we're in STAC, there's a data cube extension. So I think we're sort of more like, hey, we can represent like at the sort of highest level, like these are the things that are in this. One could see, so it's like, it's almost more at the collection level. Like, then that's what OpenEO does is, yeah, they kind of represent n-dimensional data cubes. So it's like STAC is useful to say, hey, this is what's in that. In terms of the item level, it maps less well. I'm open. I mean, I would love more time to get my head fully around it because I'm not fully up on n-dimensional stuff. Like, it's like a suspicion that something in there, but I also think like, that community is so strong with the NetCDF and the new X-ray stuff and all of that, that like, I think it's less clear to me that there's like a super obvious place for STAC at that deeper level because they're thinking through all of that. So I think it's kind of more at the, can we help make it available on the web a little bit more? Yeah, I mean, kind of a roundabout answer because, yeah, I think the core thing is I'm not totally sure, but we're definitely psyched for kind of more interchange and collaboration. And yeah, I would love to get, like, the one thing that hangs out there for me is there something that we could do in the STAC structure? Because we kind of assume the item to catalog like multiplicity in one direction, and you could see a way where n-dimensional represented more tweak some of that. It'd be great to get that before STAC 1.0, just so we could make sure we can handle that flexibility. But it's basically going to take somebody who's deep in that data and willing to dive into STAC to kind of see where it falls short and, make an attempt to represent it, and then hopefully, let us in STAC know, I need to tweak this, I need to tweak this.
So I think there are a lot of similarities there to, or there are a lot of things to maybe be learned there from the cloud optimized GeoTIFF, because like in the case of NetCDF or Xarray, if you use the analogy of cloud optimized GeoTIFF, the blocks, the chunks or whatever of NetCDF or Xarray are kind of synonymous with the chunking scheme of the GeoTIFF that's stored in objects. And you wouldn't store those chunks as individual spatiotemporal assets. You would store you'd reference the collection because it is a collection.
Yep.
And I think people read a little too much into kind of the granules of remote sensing and try to draw that analogy. So anyways, it's really an interesting area, especially when you get to the more than 3 dimensions. I mean, 4 dimensions is reasonable to see how you might go forward, but beyond that, it all kinds of falls apart in my head.
Yeah, I close out, but yeah, I think I'm at the same. I think I got to that same point of like, yeah, like having STAC truly help the internals of those granulars. I don't. It's like use what you have. Don't try to fit into this. But yeah, if you're thinking about representing that out and have a reasonable collection size, I mean, to me, it's like, what does somebody want to search on? That's what fits in STAC. If you're things that no one's going to search on and wants to discover, like, yeah, you don't put it in.
Hey everyone, it's Annie. I just wanted to make sure we didn't miss Chris's question.
Yeah, I was going to go back to that.
Linus question. Chris, could you check that out? How does the static catalog deal with data deletions?
Yeah, so we've thought and brainstormed about it. No one has that kind of extension implementation yet. I think it's mostly because most of the initial sets of data are, satellite imagery, LiDAR, things that aren't doing much data deletion. So kind of none of the people, basically like we're very much, somebody has to have this use case. We're not gonna imagine how this could be. We're gonna wait till this use case exists and somebody has to implement it, and then they bring it up to the group. So nobody's actually needed to deal with data deletions yet, because most of the catalogs are sensors that are just putting data down. At Planet, we are probably closer to that because we sort of do some stuff like we've thought about using it as like a wire format to kind of move to like an air gap network. Moving across the wire, you have a catalog internal to your firewall, and then we just send kind of STAC updates. So I think that's like the first thing is just how do you even get an update or a diff from a STAC that says, this is my catalog, but I'm sending it across. I last got this update, so send me this little mini STAC that I incorporate. And don't have an extension for that yet. But then that sort of, I think it's within that context where you naturally get that question of, what about data deletes? Planet maybe does some of that, but you can certainly imagine use cases where there are data deletes. Like I only want the last week on my mobile device. Delete the things that are over a week old. We know that it's a thing to think about. Don't have an answer yet because no one has actually got to the point of trying to use STAC in that use case.
So I can especially see that for model data.
I think we're almost at that point. I'm from EOS DIS at NASA, and we do a lot of data deletions and replacements with pre-processings, with near real-time data, which rolls off the archive. And we've been asked to implement a STAC response, essentially, or a static catalog for our common metadata repository.
Oh yeah, awesome.
Well, I like your use case name. It's the asset tombstone.
Yeah. I mean, I would say like if you guys are on the bleeding edge, and I'm pretty sure there's STAC people working in that stuff. Like implement what feels best to you. Like see how it works, and then make a proposal to STAC, and hopefully one or two other people is playing with it a bit. And but I think there may be more people playing with it, but then it's kind of the people who show up every week that comes up. But I think once you get something in there, then a lot of other people will be like, oh yeah, I did this or I did this. So
cool. Well, unless there's other questions, I think we could probably call it there about 5 minutes early.
I have one more question.
Yep.
Yeah. So, Chris, for the long tail folks, I'm some person who I've got 10 images or something, and I put them in a bucket somewhere. Then what do I do? I create a little STAC catalog and.
So, I mean, the answer is not fully fleshed out in terms of like, but basically where I want it to be is like, I put that in, I put them in a bucket, run a little thing to like format as a STAC. And the next thing would be, run stack browser, which can generate static HTML pages. So then you have a static HTML page that's crawlable by Google and the same thing. And then ideally, that has like your web, that like crawler, I forget the name of the file, but that root thing that you point Google at, and you either, you link to it from somewhere, your catalog, in those pages, and then it gets crawled by Google and starts to go into that index. I mean, practically at this stage, you also probably let the community know and we put a link to your thing, but that longer term, I think that goal is, run the transformation to HTML. That tool will encapsulate all the best practices of, Google data search and JSON LD and schema.org and micro formats and all of that in that HTML page, has some nice templates, you maybe put your logo on, and then you have an HTML version, and then that gets crawled. And then, the bigger vision is more and more than just Google starts to recognize that there's imagery there. And you maybe submit to like some places to say, hey, crawl my thing, but hopefully get to the point where it's just links out.
Yeah, cool.
Or also like, point at SAT API, because that's the other one is like, you can even have like a Docker container, like SAT API is able to point at any static stack catalog, and then you get a STAC API. So it's like if you wanted to provide a search or wanted somebody else to provide a search, like run that as a, Amazon function, and
Got it. Cool.
Cool. All right. Well, thank you very much, Chris. This has been really interesting, and we'll get this converted over and up on YouTube for everybody to share around. And look forward to crossing paths again, and we'll talk to everybody later.
Awesome. Sounds great.
Thanks, David.
All right, thanks a lot, everybody. We'll see you.
Apologies for all the hacking costs.